so that I don't have to stand up to the math thing. Alrighty. So we've got here a poster underneath me. There we go. Okay, I'm going to slide off. I'll bet it. Okay, so we've got here that somebody's got a baseball cards collection. And that we have that B is the number of cards that they have. And that T is going to be some unit of time. It's time in years. So B is the number of cards, and T is how many years since they started the collection. So we want to know, I'm just going to redraw that purple because that looked weird. There we go. We want to know what these equations mean. What does this tell us is happening about his card collection, or this person's card collection? So let's look at this equation here. Let's look at A. It's the first one. What do we know about their card collection? You gotta be louder. I'm old and my ears aren't great. You gotta be louder. They have 200 cards. That's how much they're starting with. So maybe it was a present, maybe they found them, maybe they bought them at a garage sale. Who knows? So they started with 200 cards. There we go. What does the other chunk tell us? What does this piece tell us? They get 100 every year. So they're buying 100, they're finding 100, they're collecting 100. And they add 100 each year. So if they start with 200 cards and they add 100 each year, that would be this equation. What's different between A and B? How does the situation change for equation B?
Because it's 100, they start with 100 cards.
Yeah, this time they're only starting with 100 cards. So the number that doesn't have our variable is how much they're starting with. If we think about this, the one we're most familiar with, that's our y equals mx plus b, that guy. The number that doesn't have a variable, that's our y-intercept. It's our starting amount. That's these numbers over here. I am using the wrong color there. Boop. See pink. So the B is what we start with. That was this 200. That was this guy. So they're starting with 100 in this case. So starting with 100 cards. And how much do they get each year? Yeah. And they buy 200 more, collect 200 more, obtain in some way, shape, or form, hopefully legally. They're not stealing them. But their collection grows. Increases is a fine way of wording it. There's a lot of ways to word it. By 200 each year. All right, what about for C? What's happening there? They're starting with the 2,000, so our starting has changed significantly. So we're starting with 2,000 cards, and what's happening? They lose 100. They sell 100. 100 fall into a puddle. They catch on fire. Who knows? But every year they're losing 100 cards. Most likely they're selling them, but that was dramatic.
For insurance purposes, they lose them.
For insurance purposes, they're losing them. Starting with 2,000 cards, and they lose, except you lose an O and lose, there we go. Lose 100 each year. And then our bottom one, They start with how many? 100. And they lose how much? 200 each year. So when do they run out of cards?
Half a year.
Half a year. Because if they're getting rid of 200 in a year, they don't have 200 cards.
They're already dead.
Well, we can't have negative baseball cards. That's like
They owe people baseball cards.
they owe people cards. Yeah. So this is starting with 100, and they're losing 200 each year. I have like none space to write, so y'all have space on your page. I have none space, just because I like to have them all on one page and not have to flippy floppy to get to stuff. Okay. Not on a slide. Not on a digital slide. Huh? Uh-huh. I was making a playground joke. Not on a digital slide. This would not be fun on real life slide. Whee. Okay, so we can look at equations and put them into context. We can look at context and put it on equations. We can do all kinds of stuff. We've been playing a lot of stuff of contextualizing. So the next thing we're going to look at on the next page, which is again probably the wrong page number, except I think it might actually be right, is we have a whole list of stuff with options. And we are given a linear equation. We're given a y equals mx plus b. We're given this guy here. 2x plus 5. Somebody's music is very loud. And what I want you to do is I want you to look at this whole page all the way down to f. I want you to see if this equation matches the situation or not. And if not, can you find the right equation? What would it be? Okay, and you guys can work together on this. Talk to each other. Interact with humans. Talk to each other. Okay, I want you guys to work together. Talk to each other. See what we can come up with. See if these 1, 2, 3, 4, 5, 6. We got 6 of them here. Do they match this equation? And if not, do we know how to write that equation? See what we got. Give it a shot. Take like 10, 15 minutes to look at it. Okay? And like, you can ask questions. That's okay too. We'll talk through them. But I want us to try it. See what we can do. See what we can do. 5, 10 minutes on this one. Run plus the next week. We got 3 more after that. Visualize that. Not yet updated date on here. Eraser. There we go. Talk to each other. Work together. Look at things. Erasers as soon as I grab one. Guys, I don't have to talk the whole time, guys. I don't listen to me talk that much. They're not going to be saying that it's subtracting, it's just saying that it's spreadsheets, but I can 100% see the logic in that. Absolutely. There's a difference. 100% I see the logic in that. 100% I'm right on with you. I'll just say and some of these we might not remember, because some of these we have making equations like it's a algebra. Yes, sir. I don't know what you dropped. Somebody dropped a microcord.
Oh.
you want to use I put it as was. I was gonna say it might be yours, because it's, I'm probably your charger.
It wouldn't hurt, it's probably yours. I found out when my mom found that's a really. Yep. These are.
So for this one,
Mhm.
it's the same time. They were good, but they were good. So I was.
Alright, but this ain't good. You saying this one good?
Yes, yes.
Did it not
$2 for
Yeah.
every
When
hour.
we're not using the charge, so it was a minus five. I don't know.
So I was gonna say, so that's, it's just kind of worded here, right? Yeah, cause it's charging $2 and it's charging $5. So we can think about it in a few different ways. Yeah, and so if you would do them all as charging negative, that's totally okay. If you do them all as positives, cause they're both applying the same fee, I get that too. The writing of the equation sick is not text, that's me going, ha ha ha, we're gonna practice. Alright, so what do we think? If there are initially 5 rabbits on the farm, and each month the number of rabbits is twice or 2 times the number in the month before, is that what this is? Does it say, when in doubt, kind of make a list of values? So if we start with 5 rabbits, how many are in the next month? If it is 2 times. If they start with 5 rabbits, how many rabbits do they have on the next month? 10. How many do they have on the month after that? 20. How many do they have in the month after that? It's twice that, right? So 40. Does this match up with a line like this? Is it increasing by 2 each time? Mm-mm. No, this one's not. If it was increasing by 2, we would be starting with our 5, and then we would add 2. So we'd have 7, and then 9, and then 11, and you're adding 2 each time. Yes, dear. Oh, I'm locked. There we go. Thank you. So we're adding 2 each time. This slope of 2 adds 2 each time. So we'd have 5, and then 7, and then 13. So when in doubt, kind of look at your situation and see if it matches up. So for this one, if we wanted to write a proper equation, this would be, we'd have to remember from algebra because it's actually an exponential function. This would be that we started with 5 rabbits, and every month it multiplies by 2. So it would be 2 times however many months it is. So it would be 2 to the x. We're not going to do tons of stuff like this. We'll deal with exponential functions when we get into chapter 7. We'll work with something like this. But we've seen them just in algebra. It's been a hot minute. So let's look at B. What do we think? Does this one match this equation? If he gets $2 for every magazine sale, and every time he makes a sale, he gets a $5 tip. Ooh, I hear debate. I love that. I like debate. Debate is good. Good debate. So if he sells no magazines, he gets no money. We see that. If he sells 1 magazine, he gets $2 for the magazine and his $5 tip. If he sells 2 magazines, he'd get another $2 for that magazine and another $5 tip. So he would have 7 here. So far, that's looking okay. But here we're adding to that 7, the 2 and another 5. So we'd be adding this to that. So it would wind up at 14. If he got another magazine and another $5 tip, he'd get another $7. So then he'd be at 21. So does this match 2x plus 5? This one would be $2 for every magazine and a $5 tip for every magazine. So we'd have 2x plus 5x because he's getting the $5 tip every single time. If he got a $5 tip and $2 for every magazine, then it would match up. But since they said he gets that $5 tip every time, each time he sells a magazine, he also gets a $5 tip every single time, then it doesn't match up. Okay? It's that every single time that does it to us. So this would be what our equation looked like for this one. And C, I can see them kind of tricking us a little bit on here, but we're going to see because the wording on it's a little bit weird. How would we write an equation for C? What would we think? So we've got $2 an hour, and that's absolutely one argument I see is $2 an hour. I was going to say, if we're doing charges $2 an hour and charges $5, I could see it being minus 2x and minus 5. Or since they're both charges and she's charging somebody else, I could see the logic for 2x plus 5. This is what the parents are spending. This is what she's earning. So they are very, very, very much related. And it's a matter of the words are weird. I don't like that they say they charged because I agree. That is one of those code words we've been trained to look for to say minus. I don't like that they put charged in there. She's charging would make us stop and think a little bit harder than charge. Okay, so this one, they say yes, it does, because they're looking at how much money she makes. She is making that $5 and she's making that $2 per hour, which she needs to up her prices because that is not cool. She better be like 10 to make that much money babysitting. If you babysit and charge $2 an hour, up your prices. Not good. All right, what did we think about for D? What do we think? We've got that we have a sequence of integers. Integers are our counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. The first term is 7. And the difference between the consecutive terms is equal to 2. So what would the next term be if we went up? If the difference between them is 2. I would say I can see the argument for 5 as well. Again, they've used one of those kind of code words. What they were intending for you to do was to go 7, well, plus 2. The difference between them is 9, and then 13, not 13, then 11, and then 13, and then 15. So trying to see that pattern, that if I went backwards to term 0, so a starting place would be 5, and increasing by 2. Again, their wording is bad, and I will make sure that whenever we're doing things on like paper and doing things on things like chapter tests or reviews, that music is so loud. That needs to get turned down. I will make sure it's very clear, and I will not use those code words that we have learned mean other things than this, because this is mean. Because they're intending this to be a yes. It starts at 5 at term 0, and it increases by 2 each time. Even though they said difference, they're meaning the change between them. So when they say difference, they mean change. It doesn't necessarily mean subtraction, it means the change. So this one is intended to be a yes, but again, they're being weird and pedantic. All right, what about E? What do we think? Sneak preview is a members only video rental store. There's a $2 fee to start, and then $5 per video.
No.
I'm with you. What would the equation be for this one?
2x minus 5. No.
How much would he pay? He would pay $5 every video, right? So it would be our 5x. So if he gets 2 movies, it's $10. If he gets 3 movies, it's $15. And he also has to pay that starter fee. So he's also paying the $2. So this one does not match. It's close. It's got all the right pieces, but they're in the wrong spots. What about the last one? He begins saving with a $5 gift and then saves $2 every week. So, yeah, he starts with $5 and he's adding $2 every week. So that one matches up. There's a lot of these where there's some debate on it. And when we get into words in our math, that's where that happens a lot. We'll get debate on what things mean and which way things are intended. Whenever I give you something that we're doing an assessment on, I will make sure it is clear. We should not have debatable pieces when it comes to like a test. Okay, the last piece we're going to do is we're going to look at number 3. And I know it's right at the bottom of the page. On the next page, there's a whole big sheet of graph paper. Because what we're asked to do is we're asked to write an equation. And we're going to make a plot. You're going to draw your own graph. So we've got a checking account that's set up with a starting balance of $4,800 and $400 is removed every month. No other transactions. So we want to write an equation, first things first, for the money in the account. How do we write an expression like stuff on the previous part? For an account that starts with $4,800 and $400 is removed. How can we write our equation? What you got, Cameron?
Y equals
Mm-hmm.
4,800 minus 400x.
Our 4,800, that's our starting amount. And we are removing $400 every month. So month 1, we remove $400. Month 2, we remove $800. Month 3, we remove $1,200. So like it's removing $400 each month. And that's going to equal our balance. So for part A, they want us to put in that we want to know X when our balance is 2,000. So the equation they're wanting us to write here is we want to know when this chunk, when our balance is $2,000. So for part A, if you have it switch the other direction, that's totally okay. If you put it as 4,800 minus 400x equals y, totally cool. If you put 400x minus 4,800, not okay. Okay? So what they're wanting us to do here for this part is to put our 2,000 equals our 4,800. That's what they mean when they say substitute in, find the number of months it would take to reach $2,000. And what we're going to do is we're going to look at that by graphing. So on the next page, we have a graph paper, and you get to draw your own graph. It's just a sheet of graph paper. It doesn't have any grid on it. So you're going to need to draw somewhere on that page. You don't have to use the whole thing. But you're going to draw somewhere on that page a graph that kind of looks like this. What does our x mean? When we wrote up here, we wrote 400x. What does this x mean? It's the number of months, yeah. So our x's are going to be months. So when we're counting that, usually when we count months, we're going to count those in like 1, 2, 3, etc. And you're going to do this on the graph paper. I'm just eyeballing it right now. And they want you to go all the way up to 11. So we're getting all the way pretty much to a year. For our y, what does our y stand for? What is this piece? Say it louder. Yeah, it's the balance in the checking account. It's the money. Money, 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 money. And what are we starting with for the balance? What's our starting place? Dude, that's so loud. We're starting with what? 4,800. So should we count by ones? I do not have a graph paper with 4,800 squares. So you're going to have to figure out what you're going to count by. It depends on how big you drew your graph. You might count by 100s. You might count by 1,000s. You might count by 400s. Whatever you want to count by. So you're going to have to figure out what those pieces are that works for you. Because we're going to plot up some points and see what they are. I'm going to do 1, 2, 3, 4, 5, 6. I'm going to count by 800 just because I made my graph kind of small. So I'm going to count 800 and then 1,600. You do not need to count the same scale as me. Nope, I missed one. Boop. 2,400, 3,200, 4,000, and 4,800. So when we're graphing this equation, we're going to need to figure out where we start. Where is my first point going to be? Where do we start? At the 4,800. We always start with the guy that doesn't have a variable. So I'm going to start with that's my y-intercept. That's this guy up here. We're starting up there. It's how we started our account. It's where our initial balance. It's our y-intercept. It's up here, our beginning. That is what happens at month 0. Then what we're going to do is we're going to plot these up. So at month 1, what is the balance in his account? Yeah. He spent $400. So it's going to be down $400, which will be different on your scale than mine. Mine is a half a space, kind of. I'm eyeballing it. So at month 1, we should be at $4,400. At month 2, what's his balance? Yeah, it goes down another 400. So month 2, we'd be at $4,000. So it's gonna go down like this. So every month he goes over, it's gonna go down $400. Which mine is gonna like struggle because of thing. So plotting this up, we're kind of doing a plug and chug or a guess and check. We can also use this slope, and on yours it'll be easier to do because we can go down 400, down 400 over 1, down 400 over 1, down 400 over 1. We're just gonna have to make sure we count by something right. Once we get enough points, we can plot it up and get our line. So go through this and try and plot some of these pieces up. Because my question for you is, when does he have $2,000 in his bank account? Or when do we have $2,000 in our bank account? Because there was no person given here. At what month will we have $2,000? What do we think? When that means x equals what? I'm listening. It is at 7 months. So at 7 months, you should be right around 2,000. Which I didn't do horribly with my eyeballed graph. We should wind up right at 2,000. So at 7 months, you should have been at 2,000. Okay. When does he run out of money? At how many months? Can you tell if you continue your line? When do we run out of money? Forgetting there's no person on this one. When do we run out of money? Yeah, 12 months or 1 year. So if you keep going, which I can't because I'm not a graph, I'm not a screen. It would go all the way down and it would hit 0 right at 12. You can also do that like up here solving stuff. If we wanted to know when it was 0, we would put 0 right here and we'd solve it that way. Okay? So we're going to keep working with things being in context and working with context and kind of analyzing those kind of deals and working with some interesting situations over the next few days. There is homework 3 is up here for this. It's not like due tomorrow or anything like that. We'll have time, because I know we're really close on time today. We'll have time over the next couple of days where we can have more time in class to work on it, because some of them are a little tricksy, but it is the independent practice questions that should be like the next page, I think, or the page after. It says independent practice, and question 1 is about Cedric and Josh. So those will be the questions that are on homework 3, but they're one of those we're writing equations out of the story. We're going to practice some more with that tomorrow as well, and we should have some time tomorrow to work on it in class just because we are about 4 minutes from the bell, and I know by that point we'll barely get Canvas open, let alone have a chance to work on it. So, yeah, that's all I got for you today. If you want to work on this one at home, great. If you want to wait and work on it tomorrow, we should have some time in class where we can work on that too, and do the thing. I will, my goal today after school is to get all of our homeworks graded and put up into Skyward, because I know they're kind of just sitting there waiting and not giving us anything information on them. So that's my goal for after school today, okay? So by tomorrow, we should have all of the homeworks that have been turned in so far graded and in Canvas and in Skyward. Just because I know I've been kind of dropping the ball on that one.